Good day. Welcome to your first further math class of Key Stage 4. And definitely, it's nice having you here because I definitely know you're going to enjoy you being a further math student. Today, we're going to start with indices. And that's the first topic from your POS if you check your POS very well. Now the first topic you should learn is what we title indices. And I know you're not new. Indices is not something you're meeting for the first time. You've always had to solve indices for one reason or the other before now. But before we go on, I would like to test your understanding just to know. Maybe some of you have used it to eat food and you can't even remember most of the things you learned when you were still doing math at Key Stage 3. So I have a very fantastic starter questions here, and I'm going to put it up now for you to play with, and I do not expect you to spend maybe about 7 minutes on all these questions as they look too easy, and I mean very easy. Okay, look, so these are the questions coming up. Good. So I'm going to give you about 7 minutes to play around this question, and let's see the results you would be able to generate with this. Great. Now, don't forget that when we talk about indices is the plural of index. So when I have 2 to the power of 3, this is referred to as an index notation. And from an index notation, when you have combination of 2 index, then it becomes what we call indices with an operation. Take note, with an operation. So when I have 2 to the power of 3 times 9, this becomes indices. And there are laws, and I'm going to quickly give you the basic laws that you should know under indices. There are some basic laws that you are required to know. Some basic laws, you learned it in year 7, you learned those laws in year 8, and you are meeting it again as an introduction into year 10. As you are entering into year 10, it is also coming at you again. And that is one of the reasons why mathematics is just so interesting and sweet, because you just keep moving from one end to another end. Now look at this. You know this as the product law. We know this as the multiplication law. We know this as the division law. We know this as the product of powers, and this is also product of powers. So in this case, it's saying this is talking about if I have x raised to power 3, y raised to power 7, all raised to power 5. I won't say the answer is x cubed y 35, which is what some of you would do, but that is absolutely very wrong. So what you do is that x raised to power 3 times 5, y raised to power 7 times 5, and that will give us x to the power of 15, y to the power of 35. That is what that particular law is actually talking about. Now, we know something. There is a big question I want you to be thinking about as we move on in this topic. Now, we know that a law of indices says that x raised to power 0 is 1. Then the question is, why is x raised to power 0 1? Can you prove your results? Also, we were told that 0 raised to power 0 is undefined. Why? Since any value, any integer or any value to the power of 0 is 1. These are some big questions that I want us to look at in the course of this particular topic. So keep thinking about it while we proceed with our topic. Now, there is another kind of theorem we call the negative indices. Now, I'm sure that's not new to you, that there's a theorem we call the negative indices. And what does negative indices, what does it mean? That if I have x to the power of minus a, the result is always 1 over x to the power of a. Also, we have what we call the fractional indices. We have what we call the fractional indices. And what this means is that when I have my x to the power of 1 over a, the result is always the 8th root of x. And if you have x to the power of a over b, it gives you the bth root of x all to the power of a. Now these are fractional indices, and that is the reason why. Now I'm going to show you something very quickly. The fractional indices is what led to the square root of 4 to be written as 4 to the power of 1 over 2, which gives us a result 2. That is what happens. So that tells me that if I have the cube root of 7 in index, I can write it as 7 to the power of 1 over 3. This is what we call fractional indices. All these things are just normal things you would learn in math. So these are what we refer to as the laws of indices. But at further math level, this is not what somebody is going to give to you. How do you apply this to do quite a number of things? How do you use this to solve more complex questions? How do you use this to solve questions that are more complex? And that is actually what we want to really look at. So all these are just like we're playing around. And trust me, we are actually playing around. Now let us examine some wonderful questions, some brilliant kind of questions. All these questions are easy peasy. 1 second please. I just need to look for a very interesting kind of question that is much more challenging. Now let's look at this example. This is a typical example of what you should be learning for indices for the math. Now look at this question. The question says that given that y is equal to 1 over 16x squared. Now I need to clear this first misconception, and I've seen students make a lot of mistakes with this. And what is that misconception? That 1 over 16x squared is not the same as 1 over 16 this. They are not the same. They are not the same. It is important to note that they are not the same. It is important to note that they are not the same. They are not the same at all. At all, at all, at all. So what am I supposed to do? Given that y is equals to 1 over 16x squared, express each of the following in the form kx raised to power n. In the form kx raised to power n. Now when you're solving, you need to always take note of these basic instructions. They are very, very important, because when you do not express your work in that form, you could lose a mark, which we call the final answer mark, and that is really important. You have to take cognizance of that. Okay, so let's look at this. Now we want to do y raised to the power of 1 over 2. What is my y? 1 over 16x squared raised to the power of 1 over 2. Now the 2 here is affecting x, but the half is affecting the whole thing inside the bracket. So you split it up, meaning we're going to have 1 over 16 raised to the power of half x squared times half. And 1 over 16 raised to the power half means the square root of 1 over 16 times x, which is equals to 1 over 4x. Secondly, it is as simple as that. But trust me, it is very easy to mess it up if you did not understand this particular misconception. Very, very important. Very, very key. Very, 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 very important. Okay, now let's look at the second question. The second question says 4y to the power of minus 1. So the minus 1 is affecting what? Y, not 4. So that means we have this to be the same as 4 times y raised to minus 1, which means we're going to have 4 times, what's our y? 1 over 16 x squared, all raised to the power of negative 1. So what do? We'll solve what we have in the bracket first, and that will produce what? This will give us 1 over 16 raised to the power of negative 1 x raised to the power 2 times minus 1. When you're doing negative index, what you do is you invert what you have in the bracket. So that means you reverse it, you flip it around. So that means 1 over 16 raised to the power of minus 1 will give us 16. So x raised to the power of minus 2 times this 4. And that will produce 64x to the power of negative 2. And that gives you your result. So these are the kind of questions where you have mixture of different laws coming in together when you are solving. And that is one of the reasons why you have to really pay attention to those little details. Now, I'm going to solve a couple more questions. Then you will have quite a number of things to play around with on your own as well. We're going to solve a couple of questions and you will have quite a number of questions to play around with. And trust me, we're going to be using the IGCSE papers really well. We'll look for the questions that we've seen on indices in the last maybe 5 years. We'll be able to do it, and with that you keep yourself acquainted to what the exam body usually give out to students. So now let's look at the first question. The first question is really easy though. So this will give us the 4th root of 81, and that's equal to 3. For this particular question, you will have x times 2 to the power of 4 times x raised to the power minus 1 over 3 times 4. And that will give you x times 16 times x raised to the power minus 4 over 3. So let's bring this down, and that will give us 16x times x raised to the power minus 4 over 3. Now go back to your law of indices. That is the law of indices, the multiplication law. This x here means x raised to the power 1. And when there's multiplication, what do we do to the powers? We'll say 16x raised to the power 1 minus 4 over 3. And when you do that, you get 16x to the power of negative 1 over 3. They didn't tell us to put it in any form, so we would leave it like that, since we were not told to put it in any form. Okay, so now let's look at the second part of the question. We have our y to be this. Now the first question says, what will be y raised to the power 1 over 3? So that gives us 1 over 8 x raised to the power 3 all to the power of 1 over 3. Don't forget, you must always split it out. So that gives you what? 1 over 8 to the power of 1 over 3 x raised to the power 3 times 1 over 3. So 1 over 8 raised to the power 1 over 3 means the cube root of 1 over 8 times x, because 3 will cancel out 3. And the cube root of 8 is what? Half. Cube root of 8 is 2. So cube root of 1 over 8 will become 1 over 2. So that gives us 1 over 2x. And I use another marker to do the b part so that it doesn't confuse you. For the b part, we have half y raised to the power minus 2. So that gives us 1 over 2 into bracket 1 over 8 x raised to the power 3 raised to the power minus 2. As I said before, you have to split it up first. So that gives you 1 over 2 times 1 over 8 raised to the power of minus 2 times x raised to the power 3 times minus 2. Could you just think within yourself, why did I split it up? Why didn't I just do it directly? Think about it, answer the question within yourself, and we're going to talk about that when we also come into the class. So this will give us 1 over 2. Now I told you when you have a negative index, you invert what you have in the bracket. So that means this will become times 8 raised to the power 2 times x raised to the power minus 6. And that will give us 1 over 2 times 64 x raised to the power minus 6, which is definitely going to be 32x raised to the power minus 6. Good, 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 good. I hope you've been able to understand clearly what we are talking about here. So I'm going to tell you to try a question very quickly for me. Just 1 second, please. Good. I want you to think about something very quickly. Now, we've been talking about when we have same base, same base, same base. Now, what will happen? Think. If I have 2 raised to power x times 3 raised to power x, what will this give you? I will come back to this. Okay, so I give you like 2 minutes to think about this, and let me see what you get. But honestly, it's not more than 10 seconds question. Okay, so you could pause it and look at what it's going to give me. It's going to give me 6 raised to power x. And you're like, oh, Mr. Toby has done magic. What did you do? Good. The bases are different, but the powers are the same. So when this happens, what you do is very simple. You just multiply up the bases and pick the similar powers. Now let's check. Let's check something like 2 raised to power 4 times 3 raised to power 4. Applying this law, we'll get 2 times 3 all raised to power 4, which is equals to 6 raised to power 4. Now, let's do the literal check. 2 raised to power 4 is 16. 3 raised to power 4 is 81. What is 16 times 81? 16 times 81 should definitely give you 1,296. And if you also try 6 raised to power 4, you get 1,296. Yeah, that's it. Good. So you will play with this as part of your activity. Sorry, I just have to get all these things from different places. I just have to pull them up different places. Okay, so I got it. I got it. Now, somebody be like, where's Mr. Toby getting all these books from? That just cropping. Don't mind me. That's one of the things. That's why I'm a teacher. Okay, so you play with this. Good. Now, I want to quickly introduce you to what we call indicial equation. Hey, somebody's like, oh, Mr. Toby has come. What is indicial equation? Good. We have what we call the indicial equation. That is equation involving indices. And we also have what we call the exponential equation. They're practically the same. Now, 2 things matters here. Indicial equation leads to 2 kinds of things. Now, it is either the indicial equation leads you to a linear equation, or it leads you to a quadratic equation at your level. Though it could lead to cubic, quartic equation, as it were. Maybe at the A level, at the advanced level, at the 6th form level. Now, what indicial equation does is this: solving equations in indices. So for example, if I have 2 to the power of x is equals to 8, what is my x? As a smart child, you just say, oh, x is 3. But I could solve this out. How? By making sure that the base on the left hand side and the base on the right hand side, they are the same. So what do? That means I will have 2 raised to power x is equals to 2 raised to power 3. 2 will cancel out 2, and that means x is 3. Oh, really easy. Good. But here is another twist. Now let's see another twist. And this is the other twist. When I have 4 raised to power x is equal to 8, how do I do this? Think about this for about a minute, and you can pause and come back into the work. Now, it is obvious that I cannot express 8 as a base of 4. So when that happens, what do? All I will do is to do what? is to try as much as possible to make the bases to be the same. So 4 will give me 2 raised to the power 2x, while 8 will give me 2 raised to the power 3. 2 cancels out 2, and 2x is equals to 3, which means x is equals to 3 over 2. Yeah, that's it. Hope you got it. Good. Now, let's look at solving something very quickly. How this will lead us to a proper linear equation. Solve for x if let's say 8 raised to the power 2 into bracket x plus 4 is equal to 16 2x minus 5. No, 3x minus 5. So what I will do is, can I make 16 a base of 8? No. So what I will do is, I will express them. So which means that my 8 will definitely become 2 raised to the power 3 into bracket. This itself will produce 2x plus 8, which is equal to 16 will give us 2 raised to the power 4, which is into 3x minus 5. 2 will cancel out 2, and that means we'll have 6x plus 24 is equal to 12x minus 5. And this result will give us what? 24 plus 5 is equal to 12x minus 6x, which means 6x equals 29 and x equals to 29 over 6. So you can see how this question led to solving a simple linear equation. So that is one of the major importance of solving indicial equations. And lastly is, how do you solve exponential equations? So these are those kind of equations that will lead you to a quadratic equation. And I'm just going to show you something, but before I show you something, I would like you to figure out something yourself. I want you to figure out something yourself. Yes, you could actually figure it out. You could figure it out because I know you to be smart and really smart. Okay, so we want to figure out something. If I have 2 to the power of 2x minus, let's say 5 to the power of 2 raised to the power x minus 8 is equals to 0. Solve for x. So what do I do? Going back to my law of indices, 2 to the power of 2x is the same thing as 2 raised to the power x all raised to the power 2. Don't forget the law, that particular law that we call the product of powers, minus, I just tried to change it. So instead of x coming last, I made x to come first. So minus 5 into bracket 2 raised to the power x minus 8 is equals to 0. So can I make, now I could say, let p be the 2 raised to the power x there, so that I have p squared minus 5p minus 8 is equals to 0. Please, I actually got this question from my head, so I want to quickly make a quick change. I want to change this to 6. I want to change this to plus, so plus 6, I'm sorry, comes from the head, minus 6p plus 8. So what I'll do now is, you can see that it lets me to factorize quadratic equation. So I'll factorize out this and I'll get p minus 2, p minus 4. I shouldn't be doing this for you. You guys are further math students. So that tells me that p is what? 2 or p is 4. But I'm not solving for p. The question says I should solve for what? X. So I will now go back to say, since my p is 2 raised to the power x, so when p is 2, that means I have 2 raised to the power x equals to 2, which is 2 raised to the power x equals to 2 raised to the power 1, and x is equals to 1. Also, when p is 4, I have 2 raised to the power x is equals to 4, which means 2 raised to the power x is equals to 2 raised to the power 2, and x is 2. So therefore, my x is 1 or my x is 2. So how do I know if I've messed up or not? The only way I can know if I've messed up is I put in my values into the original equation. Now don't get it twisted. This is the original equation here in green. This is the original equation. If you put it in here and you get 0, then you're right. If you don't get 0, then there is a problem somewhere. So can I allow you to test that and get back to me on that? So I put 1, I'll get 2 raised to the power 2, which is 4. I put 1, 6 times 2, 12. 4 minus 12, minus 8, minus 8 plus 8, 0. Thank you very much for this class. I hope you now know how to do indices. I'm going to post activity on Google Classroom for you to see. Bye.